Okay, YouTube. Hello, everyone. We are going to do the resistance checks on this board, and then, assuming everything is good on it, we'll move on to the next phase. I'm just going to read the points to you, because instead of trying to go back and forth to the paper on it, there's two main things we're checking. U1 is this big chip here, and we're doing the pins on that first. Then after that is done, we flip the board over, and this black thing here is the main plug between this board and the RF board. So basically the whole circuitry passes through this eventually. We flip this over, we do this resistance checks on here. I think I have everything set up so we can see it. The meter is grounded to the board with a clip, and I'm gonna read it to you as I do the resistance checks. Hopefully these all check out. I have not done this ahead of time. Doing it first live on YouTube. Well, not live, but for the first time on YouTube. So U1, pin 1, is our first check. And from ground, we want to have 25 to 35K. So U1, pin 1 is the... I know you can't see this real well. I'll give you one close-up, and then I will have to move it back after. Pin 1 is here. They go from 1 to 20 that way, and then 20 to 40 that way, 40 pins. U1, pin 1. Test. Whoops. Test. 29.39K. That's good. I'm going to write all these down in my book, which I do. 29.31K. Pin 2. Test. 29.39K. 29.39K. And that is supposed to be from 25 to 35K as well. Pin 3, we're looking for a reading between 40 and 60K. Pin 3. Test. 48.1K. Very good. 48.1K. Pin 4, greater than 50K. And it can be a lot greater, by the way, as long as it's not less. You're basically looking for open or shorts, one or the other. It's just verifying that everything's soldered together correctly. 1, 2, 3, 4, pin 4, looking for greater than 50K. $38.5M. So that's considerably higher, but that's fine. 38.5M. I know you can't read the little M, but it is an M. You'll have to take my word for it. It was K on the last one. The next one, we're looking at pin 1, or U1, pin 5. We're looking for 15 to 40K, 15 to 40. 1, 2, 3, 4, 5. Pin 5. Here we go. Test. 24.65K. That's good. 24.65K. Excuse me, I'm taking my head. I put headphones on and plugged them into my mic. I have a separate mic hanging above me in the hopes that the headphones would pick up my audio and I could monitor my audio, but it's not working. So I don't know why I kept them on. Okay, pin 6 through 11. Oh, pin 6 through 11. They are all ground, and we should all have 0 because we should be open to ground. Because the black line is already. By the way, I didn't show you that. The black clip here is clipped to the ground on the back. So this is pin 6 to 11. We should have 0. 1, 2, 3, 4, 5, 6. Pin 6, check. 1.1 ohm. That's low. I don't know if that's good or bad. I mean it's high. 1.1 ohm is pin 6. 1, 2, 3, 4, 5, 6. Recheck it just to check it. I'm hoping for a lower number, right? 1 ohm. Actually, it is going lower now. Yeah, it's leveling off at 1 ohm. Pin 7. I know you can't see the decimal point, but I can. You'll have to take my word for it. It's 0.9. 0.9. 1, 2, 3, 4, 5, 6, 7, 8. This is pin 8. 1 ohm. I think they're all going to be about the same. I don't know if that's bad or not. It's a very low number. It's supposed to be to ground. Let me just see something quick. If I go, let me zero my meter to the other clip. Yeah, see, that's even giving me a high reading, which is weird. Let me just, I never did this before. You should always zero your meter. You clip the negative to the positive and let it zero itself. It's bouncing all over the place. I wonder if it's reading resistance off this stupid clip lead. You know, that's the problem, these cheap Chinese clip leads, and I know other people have run into this, and I have too. They have a bad connection on the stupid thing. It's reading resistance through this lead, through the wire. And that's a problem. That's probably why I'm getting readings on those instead of 0. So we're going to have to do this a little. It's going to be a little clunky because I'm going to hold the probe against the ground lead instead of using that in between. That's just making noise at me because I'm not using it. Alright, see, now we're zeroed. Well, even that's not true 0. Maybe it's my stupid meter. Let me reset it. Yeah, I definitely have a feeling now that those numbers I'm getting are simply a reflection of resistance within these leads. And I'm not concerned about it at all. 0.2. Well, let's go with that. So, now this will be a little more clunky, as I said, because I'm going to hold one lead against the ground. Ground is right here. Actually, I can probably feed it in there and just hold it like that on top. There's a ground loop underneath there. Okay, I'm going to go back. Pin 6 through 11. Let's go back and just see. 1, 2, 3, 4, 5, 6. Pin 6. Yeah, that's more like it. That's about the resistance I had between these leads. I'm going to call it 0. Pin 7. Is a true 0. Oh, 0.1. Okay. Pin 8. 0.2. Pin 9. 0.2. That's what I had when I had these zeroed. Pin 10 is 0.2. And the last one, pin 11, is 0.2, which is 0. They were all 0. There you go. So those readings I was getting, let's see, 6, 7, 8, 9, I'm writing these numbers down, 10, 11, are all the resistance of that stupid clip lead I had on there. Okay, U1 pin 12 is a 2-volt line. We should have 9 to 11K on that line. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and number 12. 9.9K, and we wanted 9 to 11. That's perfect. So far, so good. I'm happy. 9.9. Okay, the next one, pin 13 to 40. All the rest of the pins, they're all part of the LCD segment. Every one of them should be greater than 50K, which again can be a huge number as long as you're above greater than 50. Greater than 50K, 13 to 40, that's every pin left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Pin 13, first one. Sorry, this will take a while. I'm going to be back and forth writing. But I want to check every one of them. This just verifies everything on this board is soldered properly and I'm getting current where it's supposed to go. Getting, not current, but continuity really is, and resistance. Continuity and resistance. 3.3, 33.8 M. So 33. You know what? I can't write all these in the book. It's too many pins. Let me get a piece of paper. I know you can't see me on camera doing this, but I'm going to write them down. Pin 13 to 440. I do apologize for this back and forth. Wow, that's really washed out, isn't it? There's my chart, and that's what I'm writing. Those are what I'm reading to you. I just have to write these out. 13. Okay, 13, albeit from a kit, not from a homebrew. Eventually I want to do a homebrew radio. Okay, that's next on the list. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I know I already did this, but I didn't write it down. 33.6 M. 33.6 M. 14, and I expect these are all going to be similar. Yeah. 37.18. 37 is close enough. 37M. 15, and that's megohm, by the way. M. 35.7. It's bouncing around a little. Doesn't matter. It's just got to be over 50K. I just want to have it written down what I got, though. Next one, 31.8. That was pin 16, pin 17. 3940M. 40.3. Pin 18. 33.9. M again, they're all M. Pin 19. 37.4 M. Pin 20. I think my ground moved. Yeah, it did. I keep forgetting. The ground is not clipped in because I took my clip lead out. .7 M. Pin 21. Now we're on the other side of the board now. I'm going to turn this. Other side of the chip, I should say. 21. 39.3. Pin 22. 39. They're all in the same range, which is probably a good thing. 1, 2, 3. 39.2. Since they all control the LEDs. 3, the number 4. This is 24 actually. 4 from the end. 39.1 M. But they're all 38 and 30, 37, 33, 31 was the lowest I had. 25. 1, 2, 3, 4, 5. Pin 25. Where are you? 40.2. 6. 1, 2, 3, 4, 5, 6. 39M. So I just got my ARRL license plate holders, and I've ordered my Vanity New York State license plates with my call sign. They come in the mail. I haven't got them yet. 1, 2, 3, 4, 5, 6, 7. I actually do not have a radio in my car yet. I have a 2-meter radio to put in it though. I just got another car. I drive older. I'm losing my ground again. I'm trying to have a conversation and just give you a little update on things, and I can't look at this at the same time. It's bouncing all over because my ground is not making good contact. Okay, that's probably better. Now, you know what? I wonder if my battery... because the whole screen was flashing on and off. Yeah, it doesn't really zero though. It's weird. It goes down to 0.2, 0.1. It should zero. I'm eventually going to get a fluke. This isn't a bad meter. It's X-Tech. It was recommended by EEV Blog. If you ever watch Dave on EEV Blog, the guy in Australia, he did a showdown on meters for the best low-cost meter, a best quality one, and this one, it was the best one out of all the ones he tested. He actually sells a nice one himself on his blog with his that says EEV Blog on it. I might even buy his eventually. Okay, pin 7, 27, really. 1, 2, 3, 4, 5, 6, 7. I gotta stop talking. Pay attention. I'm not getting a reading there. Let me go back to this one. 38.9, that came up right away. Okay, that's not got a reading. I'm on the next one past it, 38.8. That's alright. I might have a little problem here. It's just one pin. Let's take a look. Let's try the close-up cam. This is what can make a video more interesting. Pin 7. I'm getting 0. 1, 2, 3, 4, 5, 6, 7. This pin here. A lot of glare. I can't do anything about it. It's in the socket. The socket has a nice bleb of solder down here. This. Oh no, I'm sorry. That's not that. That's that other holder thing. Yeah, you know what? This will be good. If this thing doesn't test good and I have to look at, I want to check my solder joint, it's underneath the LED that's soldered in now that we did on the last step. That's not good. If I missed a pin, I seriously doubt I missed a pin. Now, I know there's like way too much glare. If I look through the, with my own eyes through my magnifier, I can see the pins coming through. I know you cannot because of the glare. I do not see a missed pin that wasn't soldered. 1, 2, 3, 4, 5, 6, 7. I'm looking at the pin in question. It indeed looks soldered. I'm going to test it from the bottom and see if we get anything different. Possibly it could be the way the pin is plugged into the socket even. I don't know. I hope we don't have a problem here, but I might. I don't know if I can get underneath that LED to test it without touching the other wires, the other leads, but I'm going to try. I'm going to move that. You can't see it anyway. The glare, I apologize, is way too much for the close-ups with that LED light. Just doesn't work. It's actually soldered to the, it'll be the same potential as the LED screen because it's connected to it. 1, 2, 3, 4, 5, 6, 7. It should be this pin. Let me go back. That's the pin in front of it, 38.3. This is the pin I'm getting nothing on. And I'm getting nothing on it. And this is the pin on the other side of it. Yeah, I'm getting nothing on that pin whatsoever. I can get in there with the soldering iron. I'm going to do it. I'm not going to try it on camera. I'm going to reflow the solder on that pin. I'm going to move on. I'm going to put down a 0 for now and check the rest of these. It would be challenging, but I can get in there. I can get between the pins with a fine tip soldering iron. I'm going to check these from the bottom. 1, 2, 3, 4, 5, 6, 7. That is the 0 one. 6 should be a reading. Yep. 7 is nothing. 8. 38.4. 9. 36.2. And again, they're all M, they're all mega ohm. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 36.2. I'm saying 10, it's really 30, by the way. 31. 37, 37.1. If all else fails and I can't get a reading, I'm going to be sending out an email to the to Elecraft about it to see what their thoughts are. Where am I at? I'm going to go backwards. It's going to be easier to count. This is number 40. 38.7. Now that I'm nearing the other end of the thing. So the first step is to assume 32.7 that I do not have continuity from that pin to the board, and that it's a soldering problem, or it's a situation where the pin's not making contact inside that socket. That would actually be probably the first place to start, is to pull the pull the chip out of the socket. Make sure I didn't bend the pin over and it's not even in the hole, which could be. In fact, I might do that on camera when I'm done doing these tests. 39, 38, 39.2, because that is a possibility. When I was putting it in, that I bent over the pin and it didn't go in the socket. Actually, I hope that's what it is, because that would be the easiest fix. 1, 2, 3, 4, 37, pin 37. Uh-oh. No, I lost my ground. Pin 37, 40.3. Pin 36, 1, 2, 3, 4, 5. 31.3. 1, 2, 3, 4, 5, 6. Pin 35. 31.2. Pin 34. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. This should be pin 34. $31.1. 2 more. 1, 2, 3, 31.5. One more. 5, 6, 7, 8, and 9. This one right there. 32.1. I think on my last video I talked about the fact that you don't want to have to pull those back out of the socket, and that is true. It's not a good thing to have to do, but if I have to, I have to. I'm going to recheck that pin. It's pin 27. 1, 2, alright, 20. 1, 2, 3, 4, 5, 6, 7. Right there. Yep. Absolute. Oh. No. Wait a minute. I thought I had I did have a reading. Oh. I do have a reading. I wonder if I got on the wrong pin though. Oh, it's intermittent. One, 2, 3, 4, 5, 6, 7. I'm definitely on the right one. Huh. Alright, it's intermittent. With a little bit of pressure, I'm getting a reading. And it's a good reading, 33.6 M. I think I'm going to have to reflow the solder. That would indicate to me more that it's a solder problem than a pin problem. This pin into the socket problem. Let me check it on top one more time. I don't want to pull it out of that socket if I don't have to either. I don't want to solder it either, but if I have to, I have to. 27. 1, 2, 3, 4, 5, 6, 7. Yeah, I got a reading now. I think just wiggling it around, I'm getting a consistent reading now. I'm doing the pins next to it too. I'm making sure I'm on the right one. 36.8. I don't know what happened there. Well, I can make a guess. I might have a cold solder joint there where the pin is kind of not totally surrounded tight in the solder. What happens is the hole gets hot, but the pin on the thing that you're soldering doesn't get hot enough, and the solder is touching it, but it isn't like adhered to it. And then when you wiggle it, you get an intermittent fault because it'll make contact, it'll lose contact, back and forth, back and forth. 1, 2, 3, 4, 5, 6, 7. I'm making sure again. Yeah, it's working now. So when I pushed on it, I got contact. So I'm just we're gonna call that a probable cold soldered joint. I'm not going to do it on camera because it's going to be hard to do and I won't be able to capture it on camera anyway with a close-up. I'm going to just reflow the solder on the very end of that pin and make sure I have a good connection. And I'm not going to pull that chip out. Okay. Well, that's why you do this. If you didn't do this and I powered it up and the LED didn't work right, I wouldn't really know why. We're going to do the tests on the other thing now. This is the connector. As I said, there's a connector. I don't have it. It's not built yet. This plugs into the RF board, and it's a similar connector to this, where you have all these pins and they plug into here. And it's your main connection between your front panel and the RF board. So we're checking the resistances on this now. And we have 20 pins total. And actually we do it on the other side. It's actually numbered on here. Pin 1 to pin 20. And our first pin should be greater than a megohm, greater than 1 M. Pin 1. The one thing I don't like about doing these, I'm zeroing this. When you're trying to do resistances or any checking into a joint that's been soldered on the bottom of a circuit board, there's flux on it, and you have to sometimes scratch the solder a little to get in there to get a good connection. And you're never quite sure if you have a good connection. It always annoys me. I'm not getting anything. Huh. I'm actually going down the line, and I'm not getting much of anything on any of these. Let me flip it. I'd rather go into the hole where the pin is. Alright, that's pin 1 is here. I don't know if this, no, it won't fit. It's not going to fit. I could do it with a piece of wire. Stick it into the hole. Try to make contact with the clip inside. That went off on me, darn it. It's the only, I mean, it's okay, it saves your battery, but it's annoying. It warns you, though. I'm not getting readings on this at all. That's not good. How could I have no readings? Even if it was open to ground, I would expect a low number. That's ground. Let me hook 2 grounds. This is a ground at either end of the pin, either end of the board. So that's my ground plane at either end of the board. I got 0.2. Now we're going to go to the pin in question. I'm getting nothing. Pin 2, nothing. Pin 3, nothing. All the way from pin 1 to pin 7 are supposed to be greater than 1 megohm. How can I get, I mean, I would expect, you know, I wouldn't be totally shocked or surprised if I had 1 or 2 pins that were off like that last one I did. But to have nothing through any pin is extremely strange. It makes me question my meter even. That pin's trying to give me a number. 0.3, what pin number is that? That's pin 8. Pin 8 is supposed to be 0 to ground. Okay, so that is to ground. That is correct. The other one that's to ground is pin 20. Let's check it. Yeah, I'm getting a number of 0.1, 0.2. And if I go over here to my ground pin, so I'm going ground to ground, same thing. But every other one that I'm supposed to be getting numbers on, and now there's a number. Alright, let me start at that end then. Pin 19. Supposed to be 1.5 to 3.5 K. I have 2.3 K. That is correct. 2.3 K. Pin 18. Now I'm getting readings. Man, that's weird. It's got to be this meter. 15 to 40 K. 24.7 K. Why would I be getting no readings and now I'm getting readings? If it wasn't my meter. 17, 20, 19, 18, 17. I'm getting readings on all of them now with no problem. 29.36K. These are all good, by the way. That one's supposed to be 25 to 35K. Pin 16. 1, 2, 3, 4, 5. That's 16. 29.3K. Same thing. And it's good. The next one I can have a range of 10 to 60K for pin 15. 30.7K. Pin 14. 1, 2, 3, 4, 5, 6, 7 from the other end. Aha. That's where they stop getting readings. So the numbers that I just read, those pins, they're all lower readings. They're all supposed to be like 10 to 30K, 10 to 40K. All the rest of the pins are in the mega are higher. They're supposed to be greater than 50, greater than 50, greater than 50. So they obviously run through a different circuit. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. Pin 14. So that's supposed to be greater than 50. That's supposed to be greater than 50. All of these are supposed to be greater than 50, and instead I'm getting 0. So they're all affected, and this one, now that one I'm getting a reading on, that's pin 10, which is supposed to be greater than 50. 39 megohm. So something's not right. That's the ground pin I told you about earlier. Something's not right. All those pins are not giving me readings. So I'm going to have to contact Elecraft. And well, before I do that, I will look at the schematic and try to see what's common to all these pins and what could possibly be wrong. It could be just one bad solder joint that's common to all these pins to this part of the circuit. I don't know. But this video is going to get very long if I do that now. So I'm going to stop. Well, I'm back already. I've solved the mystery. There's nothing wrong. This is our J1 readout. And backing up a little, this is the board that I just soldered together. This board over here is the single sideband board. And I'm looking at this going, okay, I don't have the single sideband board hooked up yet. So there's nothing connected to this. And I'm like, okay, if there's nothing connected to these, they should be all open circuit. Went to the Elecraft website. I'm going to put this back on autofocus. I hope I can get this on camera okay. I apologize for all my cords in the way. I'm going to get to the Elecraft website a minute. I'm not going to be able to see my camera well when I'm doing this, but I'm going to try to do it so you can see my answer. Oh, I can see it. Okay. I just did a search in the archives of the Elecraft email reflector on a K2 front panel board resistance, thinking I'm sure other people have ran into this problem. Absolutely have. This fella wrote in the same exact thing happened to him. He had all open circuits on every one of those pins. And it turns out it's simply how some readers read infinite resistance. The greater than is consistent with open circuit or infinite resistance. And this fella answered him and he said, Forge onward. If I understand correctly, you are correct in all ways, including technically. Greater than means greater than, and in most ways, in any way you can say it. An infinitely or open circuit is greater than 1 megohm or 50K, whatever's listed. So that 1M and 50K just is a reference to open circuit. The actual value depends on how your meter reads high resistance, and the chart is designed to accommodate all different types of meters. The exact number is would unlikely find an exception. Greater than blah blah blah. proceed forward. So the bottom line is, you know, some meters are going to read 0. Some meters are going to read this huge number greater than 50K, greater than whatever the range of your meter is. It just means open circuit, and that's exactly what I had on all of those. They were all 0. So all my other readings were good that I took, except that one pin that I think I had a possible cold solder joint on. I am going to go back and hit that with a little heat, double check it, and then stick this thing in the front panel. I think we're good on everything. So, very good. And I didn't even have to contact Elecraft. They have a great email reflector. I'll back up here. If anybody's into Elecraft, you're probably a member anyway. And there's tons of helpful people on there. The founders of Elecraft get on there and talk all the time. At least the one guy does. And you can search the archive for any information on any Elecraft and any Elecraft product, and the answer's probably there. And if it's not, there's people on the reflector which will help you with any problem you've got. Extremely nice, helpful people. So, moving onward. Thank you for watching again, and I will again say 73.